Dear participants, dear students and young researchers, distinguished speakers and guests, respected colleagues, good morning everyone. Today is another wonderful day as we begin our second summer research school on gravitational waves, new challenges and opportunities in the series of Frontier of Science. First of all, please allow me to express my sincere gratitude to all of you for coming, for our distinguished speakers, for accepting our invitation to come and give lectures at the school. The school is a very meaningful event for us, as it marks a new stage in revitalization of TÜBİTAK Research Institute for Fundamental Sciences, TBAE. It brings together motivated students and young researchers and world-class experts in the field, thereby paving the way for producing a cutting-edge knowledge for the country and for the world. More than 400 years ago, Galilei pointed his telescope toward the sky and discovered 4 satellites of Jupiter and the phases of Venus that had never been known before in exploration of the world systems. Almost 150 years ago, Maxwell formulated the mathematical theory of electromagnetism and predicted the existence of electromagnetic waves and proved the electromagnetic nature of light. In subsequent developments, the practical application of these discoveries and exploration of the universe and structure of matter in all bands of electromagnetic waves drastically changed the world and the human life. Gravitational waves were predicted by Einstein more than a century ago within his theory of general relativity. The recent detection of gravitational waves from merging binary black holes and binary neutron stars can be considered as one of greatest triumph of pure theoretical reasoning and mathematical construction of all times. Gravitational waves carry the signatures of the dark side of warp space-time, thus opening a new window on the exploration of the universe. The detection of gravitational waves also represents frontier technological challenges, such as advanced laser interferometers, detectors and quantum metrology, information and control system, modeling and simulation of violent events in the universe. The research summer school is devoted to this newly emerging and fascinating area of modern science. It is my great pleasure to introduce you our first speaker, the world-class expert in the field, Professor Scott Hughes from the Massachusetts Institute of Technology of United States. Professor Hughes' research interests cover a wide topics in astrophysics and general relativity, focusing in particular on black holes and gravitational wave sources. Professor Hughes was an undergraduate at Cornell University. Then he received his PhD in physics from the California Institute of Technology, working with Professor Kip Thorne, the Nobel Prize winner for detection of gravitational waves. Later on, the world line of Professor Hughes passed through many universities, amongst them University of Illinois, again Caltech, the University of California, Santa Barbara, and finally he became a full professor at MIT. Please join me to welcome Professor Hughes warmly and invite him to begin his lecture.
Thank you very much.